Welcome back to the class of Introduction to Petroleum Engineering. We are talking about the drive mechanisms. We talked about the production history, and we talked about how and why the composition of the reservoir fluids matter for designing the surface facilities. We discussed the impact of production history and the drive mechanisms on designing of surface facility and design of completions and so on and everything. Now today we will discuss these drive mechanisms in much details, and let's look at what they are actually. We will look at their performances today. Okay. First of all, uh, what is the solution gas drive reservoir? This is my question to all of you. What is the solution gas drive reservoir? What is it? Yes. Solution gas drive reservoir is a oil reservoir, but it has the gas dissolved in the oil. You can say like this. It's an oil reservoir which has the gas dissolved in it. The initial conditions are above the bubble point, means it is single phase, which is the liquid. As the pressure drops, okay, as the pressure drops, the gas comes out and helps the to maintain the reservoir pressure. This is the solution gas. So it has the oil, water. Okay, this is the condition. This red line is the condition which is above the bubble point. As soon as we touch this bubble point line, that is our bubble point. It means that after that, there will be two phases and the gas will come out. And when the gas will come out, it will help to maintain the reservoir pressure. So this is the oil. As the pressure drop now, this is the pressure drop here. As the pressure now, we are in two phase now. Now in this two phase, it helps to maintain the pressure. This is the solution gas drive. And as you see that we said already in the reservoir fluids that any of the line which reservoir whose line is represented on the left side is we are talking about the oil reservoir when we are talking about the bubble point line. And when we are discussing the line temperature and pressure on the right side of the critical point, it means we are talking about the gas reservoirs. So here, as you clearly see, that line is on the left side. It is we are talking about the oil reservoir. Here. Okay, here is the. Now, let's look at the pressure, how the pressure is behaving above bubble point and so on. So pressure initially is like this. And then later you see that as the volume is increasing, the pressure is reducing because they are opposite proportional. So in this kind of reservoir, the pressure is a rapid decline. I mean, it's not really a good drive mechanism, and pressure is a rapid decline in this case. Here you see, here you see that near the oil, there are small bubbles coming out of gas. Okay, small bubbles. After the bubble point reach, you see these bubbles, but before that, no. Before that, it all oil. But after the bubble point is reached, some gas comes out and it helps to drive force out. So expanding gas provides force to drive oil. This is the solution gas drive. So here it is. The gas is liberated, means free from the oil, and sometimes it causes the gas cap. So initial condition, there is a solution gas. Solution gas means gas dissolved in the oil. So when the gas dissolved in oil, here, gas later on forms a separate gas cap. Gas cap means gas forms a second separate phase and separate section. Here you see as a cap, this one. This happened in the solution. Then we have the depletion drive. Now, depletion drive, we say that when we have the force by the acting by the gas on the oil, like this one. So we have initial gas cap, means we have a gas on the top, like a cap we wear, and then we have the oil. Now, this gas cap, as we are producing this oil, this cap is trying to act like a piston and moving this oil up down. Okay, so this is another kind of the drive mechanism we are talking about. Okay. Also, this one is not really a good drive mechanism. The recovery of oil is not that good from this one also. Oil expansion is very low in this case. Here it is. Then we have the water drive reservoir. Now, water drive reservoirs are the best one, as I said. We have two different kinds of reservoirs, and let's look at them. Here you see. So there is some water on the side. It is trying to push like a piston oil, so oil moves up. This is the water drive reservoir. The drive oil is driven by water. This is the edge type. Then we have the bottom. This is the best one. Water drive. But in this case, we have a problem of water cooling. Now let's talk about what is water cooling. For example, we have a reservoir, something like this one. It has oil and it has water. Now the oil water contact is somewhere like this. This is, you can say, is a oil water contact. Okay. Then when we put the well here, sometimes what happens, this oil water contact, this water, which is water's top point is this one, this level. What happens sometimes, this water make a shape like a cone. Okay, now when this water makes a shape like a cone, means now when you are producing from this area, only water is coming. It's not because the actual water level is raised. It's not because the actual water level is, it's because the water has made a cone, this kind of a cone. So this is called the water coning. And it's really a common problem in water-driven reservoirs. When water production increases, one of the reason it could be water coning. And how to dissolve it, then it's again another complete chapter on how to talk about reduce this water coning. Now, my graduation design project was based on of this coning issue. This is the bottom water drive we are talking about. This is the edge one. Some water is helping from the side, edging one. This is the bottom one. So these are the two drive of water drive reservoir. When we talk about the combination drive, combination means water and gas cap both are acting together. So this is the gas cap from the top and water is supporting from the bottom. So in this case, the pressures are really very good and it is very good production we can get out of it. You can see original condition and after 50% still pressure is enough and we can produce really well. But in this case, definitely water production level is rising, the gas production is rising, so we have to maintain surface facilities and on that. Let's talk about the reservoir performance of each of the reservoirs. When you go on the production side, when you look at the production data, based on the production data, you can analyze a lot of things. Let's look at the first one. What we look when we talk about the reservoir performance, we look at the gas oil ratio. What is the gas oil ratio? Is the amount of gas dissolved in oil. Okay, and how much gas we have with oil, or how the pressure is behaving, how the pressure is declining, how much water production is behaving. What can give an indication of the drive mechanism? Let's look at the behavior of solution gas drive. I want to go first to this one. Okay, in the solution gas drive, we have first build up, and then there's a sudden decline. These are the production phases we are talking about here. And this is the 3-4 major points that we are talking about. Number one, look at oil production. Oil production, as I said, first is increasing because we have good pressure, but then the pressure has declined. Pressure declined faster, so the pressure declines here. Sorry, the oil production then starts to decline also. It is because you see the reservoir pressure, the first two lines, you see, if you consider the reservoir pressure on the y-axis, it was much higher, and then the reservoir pressure also starts to decline. Here. So initial pressure was good, but later on it starts declining. and gas oil ratio is increasing at the same time. So as you see, the oil production is declining, the gas oil ratio is increasing. It means that the gas is coming out of the oil and also it is traveling towards the wellbore and more gas is produced. That's why oil production is decline. Remember the relative permeability. Relative permeability of total is 1. So if relative permeability of oil is decreased, it means that something else, gas or water production should be raised. So here the relative permeability of oil has declined. So the gas gas oil ratio has increased. Now let's look at this performance. Sorry. Yes, this one. Now, initial condition, we are talking about here the relative permeability curve. In the initial conditions, look at this is the first initial condition. We have these rocks inside. It has a good porosity. The black one you see here is the oil. Then we have this lighter one, which is the gas. Now it has the gas and oil. At the initial conditions, relative permeability of gas, there is no oil. Gas is not, has no relative permeability. Gas has no permeability. Gas is not flowing, but only oil is flowing, as you can see here from this line. But after some times, when pressure declines, the relative permeability of oil, which was before 65%, here has declined to less than 20. And on the other side, the gas saturation, this is the gas saturation, relative permeability of gas starts to increase. So at some point, you see that oil permeability has quite declined and gas permeability has increased. It means now this gas here is easy to move. When we say the relative permeability of gas has increased, it means that gas is now moving because permeability is the ease with which we can flow. So there's something called critical gas saturation. When critical gas saturation is reached, means a saturation or amount of gas to the point that it starts to flow. So around 20% gas saturation has reached. Now gas has came out 20%. It has made a separate phase. Now gas can easily travel, so it has now relative permeability. On the other side, now gas is coming more, oil has declined. This is the relative permeability situation here. Here you see that now at initial gas saturation was very low, but as we are producing the oil, the saturation of the oil is declining as well as pressure is declining and gas is coming out of the oil, and so gas becomes now easy, more independent. Here you can see this blue one, and gas now can start to move ahead when we talk about the one. Okay. Size of gas bubbles increases unless critical gas saturation reaches. So there's a point reached in the gas saturation when now gas has relative permeability, it can easily move. So here gas has no relative permeability, gas cannot move. But after some saturation of gas increase, the relative permeability of gas exists now, and now gas can move to the surface easily. Now at the surface, we will have more gas production. So this you should predict it before, because you are a production engineer. Maybe if there is no gas production, but later on you might see some gas production in this case. So by looking at the production data, you can guess that what is the situation going on right now. Here you see the oil relative permeability decreases and gas permeability increases. Here you see critical gas saturation. Gas now has a relative permeability, you can see here. And oil relative permeability has decreased, you can see here. So at the initial conditions, there was no GOR. Okay. Only both were moving ahead towards the surface. But after some time, when gas has the relative permeability, gas has a separate permeability here, separate phase, and they both move towards the surface. And you have to consider both of them, this one. And in the performance, you can say that oil production increases, then suddenly decreases. Here you can see here. The similar thing you can see here, the oil production increases. So now, for example, you are designing a facility, okay, and you have to consider your money spending on the surface facilities based on your flow chart, based on your performance of the reservoir. Here you can see that the reservoir might have good production only for a few years, then it will start to decline. So what to do in this case, you have to decide that. And gas oil ratio is increasing, it means you will see more gas in the coming time. So what you will do with that? So this, you come with the production history. Production history, you monitor it, you see what's going on with that. You can see that. Initial pressure drop due to low compressibility of the system. See it, initial pressure drop. Okay, pressure continues to decline. And in the end, see here the pressure has declined. Oil production has declined. The reservoir pressure has also declined. And GOR is increasing at the same time. Gas production increases as comes out. So as a production engineer, your job is to manage this gas oil ratio. What you are going to do with that gas which is produced a lot. This is the solution gas drive. First initial step, when we are at undersaturated condition, the gas production is not increasing. But unless the bubbles point reach, the gas starts to increase. And then of course, when the lot of gas comes out, only small is remaining, then of course gas production starts to decline. But this phase is very good where you don't have a lot of gas. But the middle phase, which is the longest period after the bubble point, here you will have two phases and gas will continue to rise. Every year, if you look at the production history, every year you will see there will be increase in the gas production and so on. Maximum GOR as oil produced with the lowest low GOR. And by definition, it should be no water production because the sole drive mechanism here is the gas production, solution gas which comes out of the oil and sometimes form the secondary gas cap. Means gas make a separate phase at the top of it. Expected oil recovery is quite low, around 5 to 30%. So if, for example, if you have 100 barrels, maximum you can produce 30 barrels of it. So 30% of oil recovery is possible from this kind of well. Okay, well location low to encourage vertical gas migration. So you have to place the well in such a way that gas should be the minimum in this case. Then we have the gas cap drive. Gas cap is trying to do a piston-like movement from the top, and here you can see here in this case. Now in this case, look at the oil production. It is better than the solution gas. You see that here is the pressure. Pressure is declining, but not too much. Oil production is also declining, but not too much as before. If you compare this oil production here with this one, here you see there was a rapid decline. But in this case, there is a decline, but not too much. And gas oil ratio, of course, is increasing as the gas is coming out. Gas is coming with the oil. So gas oil ratio is also increasing. Pressure is declining. In this case, recovery is better than the previous one. So gas oil ratio early stage is ready. Let me show you is around 40%. So in the solution gas, the expected recovery was 30%. Here the expected recovery is 40% away from gas oil contact. So what you need to do, you need to place the well away from gas oil contact as far as possible. Otherwise gas will come a lot and your GOR will increase very fast. So these graphs you have to keep in your mind, because when you look at the production history, based on this graph, you can find out what kind of the drive mechanism you are dealing with. And based on the drive mechanism, you can decide the surface facilities, how many storage tanks you need, how much the gas is you are going to produce, what you are going to do with this gas, are you going to sell it or not? I mean, you have to tell all of this to the management you are dealing with. Then we have the water drive. As I said, there are two kinds of water drive. And the water drive is the best one, as I said. Let's look at their production. The reservoir pressure, okay. The gas, there's no gas, so gas oil ratio is constant in this case. It's constant. Reservoir pressure do not decline. Pressure, you can see the pressure is still also remains the constant. But interestingly, the oil production after a certain time starts to decline. Can anyone comment why this is happening? Because in this case, the pressure is not declining. In the previous cases, we said, okay, pressure production has declined because the pressure has declined. But in this case, pressure has not declined, but production is decreasing. Anyone can answer why this is happening? Okay, so let me answer for that. This is happening. The production here is declining because the water production is now increasing. As you here, this is the water production chart. This one. As you can see, the water production is now increasing. Now, as the water production increasing, oil production is declining. So relative permeability of water is now active and oil permeability is now decreasing and so on. So this is the situation. Decline. So production decline due to the water production. This is the problem here in Kurdistan. Mostly we have water drive reservoirs and water is production has raised and so on. This is the issue. Then we have the oil flow rate. Here you can see. This is the because of the aquifer. This is the side edge one, which something which is supporting from the side is edge reservoir. In this one, we have certain decline in oil production, initial pressure. You see there is a decline in initial pressure, and there is a decline in production after a certain time. Again, this decline is not associated with the pressure because pressure still is more than enough. It is because the water production is increasing. So water production wells, water drive reservoirs, usually they die or they end their life because the water production level is increasing at the certain point. Is GOR remains constant, there is no gas production, so it remains the constant here. Yeah. The decline as the aquifer. This is the water one. So reservoir pressure, this is, you can say, kind of the retrograde condensate kind of a story. Here you see there is a decline in pressure, but then there's a sudden increase in pressure. And the production is quite constant. There is not rapid decline in this so on. But here you see when this pressure is declining, the gas oil ratio is also increasing. Here. So what we are looking at in the production side, production of oil, as we discussed in the previous lecture also, what we are looking at here, the production of oil, production of water, and production of gas. Yes. So here you see there is a sudden decline in the pressure, and then there is an increase in pressure here. And production in this case stays the constant. What we are looking at in these slides right now, look at the performance of those reservoirs, how the, let's say, water drive reservoirs is behaving, how the solution gas drive reservoir is behaving, and how is the other drive mechanisms are behaving in terms of production. So we are looking at 4 to 5 major things. One of them is the oil production, how much oil we can get. As you know, we are dealing with the oil and gas industry, and our main job is to produce the oil. Oil is money. For whatever barrels we are producing, that is bringing the business to the company. And oil depends on the pressure, how much pressure we have. So we are definitely looking at the pressure. The other things that production depends upon is the gas oil ratio, how much gas we are producing and how much water we are producing. So this is, you can see there is a sudden rise in gas oil ratio, and then there is sudden rise in water production. So over a certain time, water production will also increase. So we need to look what we can do with that. Here you can see here, pressure drop due to bubble point. So when the bubble point receive, excuse me, I have one call, so just a minute. Yes. So we are looking at 4 parameters, which is the water production, gas production, oil production, and pressure. So in this case, pressure has declined initially because of the gas oil ratio has increased because there's some relative permeability plays role here in this case, and so on. But still, this is the best one. The production in this case is the highest one. Let's look at the performance one. 60% standard stock tank barrels of oil we can produce from here, 60%. So recovery is highest in this case, but it has issues of early water breakthrough. Water production may increase. Water coning is the problem. Water production is a big problem. Yes, in this case, and we have to look at it like how much is the size of the water aquifer, how much is the what is its permeability, what are the compressibility characteristics. This is needed for the reservoir simulation. When we make the reservoir models, then we have to look at the its data and history match also. This is the reservoir engineering thing we will talk about in reservoir engineering course. These things, the history matching. History match is something is that you have a computer model and you compare the history with the real history. You simulate it and you compare the simulated results with the real results and try to history match, means you try to match the real data with the simulation data. and so on. So look at this solution gas drive, what they are talking about. Reservoir pressure in solution gas drive declines rapidly. Gas oil ratio will increase definitely because it's a solution gas drive, rise through a maximum. Water production, oil production is first high and then declines rapidly. No water production, no water production. Okay, because it has no water production. And recovery is around 30%. Of course, later on it requires the artificial lift because the pressure will decline very rapidly. Okay, let's look at the gasket drive. Again, the reservoir pressure will fall fast, slowly and continuously. So again, it's really not a good trend for the reservoir pressures. The reservoir pressure fall, gas oil ratio will increase. Production rates are first high, then declines. In this case, absent or negligible. So based on these trends, when you look at what kind of drive mechanisms you have, you look at these trends, and based on that trends, you decide the surface facility. For example, it has no water production, so you don't need to do water handling there. But if it has water production, then you have to manage it, that one, water production also on the other time. Production is 20 to 40%, so it's a bit higher than the previous one. In the water drive case, the reservoir pressure is high. It has a very good reservoir pressure because the drive mechanism is water drive. Then gas oil ratio does not change a lot because the pressure remains high. Because pressure always is under saturated condition, so pressure is really high in this case. Water production is early and increase over time, and so on. Flow until water production excessive. So when water production increases too much, then maybe company thinks to stop it because you cannot manage that water. That water is not drinkable. That water is very toxic, acidic. So what you need to do with that, you need to settle down that one also. Production is highest in this case, around 60% stock tank oil initial in place. So this word is stock tank oil initial in place. Here is the recovery of three best drive mechanism: dissolved gas, gas cap, and the water drive. You can see how many percent of original oil. We said that 60 to 70% you can recover from the water drive. Then gas cap and dissolved gas. These two they require the enhanced oil recovery method. Artificially, we have to create pressure in the reservoir and produce them. So this is the original oil in place we are talking about. So reservoir pressures, water drive so far is the best one, and so on. Gas oil ratio, water drive is constant. There is no water production in the water drive reservoir. There is no gas production in the water drive reservoir. It remains the constant because the pressures usually are good and there is no gas. But on the other side, dissolved gas, which is the gas we are talking about, which is dissolved in the oil, first it is increasing and then it is decreasing when the pressure increases. And the gas cap definitely over time, the gas production is increasing. Gas pressure. This is the combination of. Usually in reservoir engineering, we deal with the graph. So whatever you do simulations, whatever you have results, your results are in graph. Your graph tells you what is going on. So engineering means, oil engineering especially means reading graphs. Reading graph, extrapolating graph, look at what's going on in the graphs and so on. So that's all about the drive mechanism. Do you have any question from drive mechanism? Yes, any question?
No, sir.
Okay. Now in the exams, if we do midterm, you have to remember these graphs, with all the drive mechanism we are talking about here. For example, how the oil production is behaving in gas oil, or in the solution gas, how the production is behaving in the other one, and in water drive and so on. So you have to discuss all of them and so on. Okay. This graph, for example. Okay. And these are the trends. You have to remember the trends also. This will come in the exam somewhere, somehow. And they are important because when you go on the field, you follow the production history and you try to analyze what is going on, which drive mechanism they have, and what is expected in the next 1 year or 2 years. Increase in gas or increase in oil. So what they are going to do with that? Do they have any plan for that? So, and look at the pressures. What was the pressure last year? What is the pressure today? And what is their plan to boost the pressures? So there are so many questions you can ask when you go to the oil and gas field, as I said, these questions. So that's all about the drive mechanisms. Now, today I posted one project and I want to talk about that. Okay, this book is from book of Tariq Ahmed, and this book has some of the mathematical questions to find the basic properties of oil and fluid and rock. So I have selected like 6 or 7 different questions, and I've given their questions also. Let me show you, for example, let's look at the this question. Now this question I have provided in the presentation also, or in the project also that I have uploaded. For example, this question, its solution is there also. For example, first you have to find out the molecular weight of butane, then you have this equation. Based on that, you calculate the volume. So easy. So, and the question says just calculate the volume of the gas, assuming the ideal gas behaviors. Okay, and of course, volume has effect of pressure and temperature. So you calculate the volume. Now, what you need to do, take this example as it is, and you solve it in the Microsoft Excel. And in the Microsoft Excel, you need to set up this formula. Okay, you have to set up these values and so on. And likewise, there are 5 or 6 different questions. I have given their page numbers also. For example, page number for this question is page number 31. And I have given like 6 or 7 different questions from easy to hard, easy, moderate to hard. And what I want you to convert them into the Microsoft Excel sheet. So you just change the values and you get the results. I hope all of you know about the Microsoft Excel, and you should be able to know how to use Microsoft Excel to solve these kind of problems. Okay, and if somebody don't know, please learn. It's very easy, so easy, and you have a lot of time, around 7 to 8 days to learn and solve that one. Yes, any question from this one? Let me share with you the project also. Let me open on the Google Classroom. So I have given, for example, following examples are taken from the book of Tariq Ahmed. You are required to solve these examples in Microsoft Excel sheet using the formulas given. So I have given like 7 or 8 questions here. For example, this question, the answer is given on page number 31. So if you go to the page number 31, you can get it. Likewise, this one is on page number 32. This one is on page number 33. This one on 35. Then on 38, and then 70, 77, and 79. So you go through those examples and just try to solve them on Microsoft Excel. Convert them into the Microsoft Excel in a workable formula. For example, if you change the value, the answer should give us the different answers. So you have to work on these examples 7, 8. Most of them are talking about the properties of oil and gas oil ratio, solution gas, and so on. For example, here is talking about molecular weight, density. Here it is talking about the same molecular weight, specific gravity, density, and so on. Here it's talking about the calculate the Z factor in one of the example. Here it is talking about the Z factor. Here it is talking about the viscosity, calculate the viscosity of the gas. Here it is talking about the PVT data. Okay. So simple questions, just go through them and solve them in Microsoft Excel and submit them. And of course, definitely, it's not like you could ask someone, your friend, to solve it for you. You have to then explain to me that how you actually made in Microsoft Excel. Maybe you have to spend 5 minutes to explain your Microsoft Excel sheet, how you set up the formula, what are the values. So you have to explain your examples later on. Otherwise, I will not accept the project, because it's not like you ask someone to do it and just submit without even looking at it. So it's not going to work like this. So any question?
Sir,
Yes.
you said we will have 20 questions for the exam.
For the midterm exam, yes.
Are you going to send the questions, or we have to find it out by ourselves on the slide?
No, I will send you the list of questions. We prepare
Okay.
from them. If we go on campus, we do the written exam. If not, we will do the face-to-face interview in campus.
Okay, that's good. Thank you, sir.
Yeah, this is the only way. I mean, so far I could find only this way, which can avoid cheating and which can be fruitful, beneficial.
Okay. Thank you, sir.
Sir,
Yes.
sir,
Yes.
did you set up the time and the date for the midterm exam?
Yes, 25 of October and 27 of October.
Okay.
Okay, 27 of October is 8th October. So on this weekend, I will already put all the questions on this weekend.
Okay.
So you will have like 15 days to work on it.
Okay.
Okay, so if we go for the written exam, it will be written exam. If we go for the oral exam, then we go face-to-face interview in camera. Depends. We will decide by 22 of October everything. But material I'm uploading in either case, whether we are going on campus on written exam or interview, in either case you have to go through all the questions, because they will not change a lot. But of course, I have to spend more time on face-to-face interviews and grading and so on. A lot of hard work for me. Okay, so thank you so much for today, and we continue our lectures and talk. If you have any question, please send me here, Google Classroom, email. You are welcome.
I'm so sorry. I'll check it. Not wrong.
Your voice is not clear.
I have a question about drilling project.
Yeah, now you can ask.
Yeah.
Those who they can leave.
Yes, Doctor. What about this project? Can you give us some other details?